All right, hello. Welcome to today's lesson. We have this last lesson of this week, a little activity tomorrow for Friday for our asynchronous day, and then we have one weekend, it's Christmas break. We're super close. For today's lesson, I want you to go ahead and just start with this do now here. This is what we did yesterday, graphing systems. So remember from yesterday, we just have to graph the first equation, make sure to plot multiple points. Graph your second equation, and then you're going to write the point for where the lines cross. So like this one over here crossed at -6, 4. So I want you to pause me and do your best to graph the top line, the bottom line, and then tell me where they cross. And then unpause me when you're ready. Or unpause me if you need help. Alright, hopefully you gave it a shot, or you're coming back for some help. So recall from yesterday that it's helpful to graph these two things in different colors so we can see clearly what's happening. So I'm going to graph this top line in pink. So we have a y-intercept of 5, and then my slope is 2/3. So I'm going to go up 2 over 3, up 2 over 3, and then we can go back the other way, down 2 over 3, and just follow that pattern backwards. And then we're going to draw a line through those. For graphing the bottom one, I'm going to do that over 1. Alright, so we have a y-intercept here of -3. Again, remember that negative sign is important. And my slope is -2 over 1. So that means I'm going to go down 2 over to the 1. Down 2 over 1. Alright, so it looks like we're going to have to go back the other direction. So we're going to go up 2 over 1. 2 over 1. 2 over 1. Alright. And then we can graph it with a line. Beautiful. Okay, we can see here that these two lines cross right here at this point where we have them overlapping. And that is at the point -3, +3. Remember, x value comes first, y value comes second. So -3, +3. All right, on to the next one. Hopefully you did okay. Pause me if you need to fill that out and it's not filled out yet. So we're going to do another systems problem. This one's kind of like an intro for today. So we're going to graph this system. I'm going to give you 2 minutes to kind of get started, and then we'll work through it together. So pause me now, take 2 minutes, and try to graph this system, and then come back when you're ready. Alright, so hopefully you came back, you finished graphing. Again, we're going to graph this first one in pink. So my y-intercept is 4. And then my slope is 2/3. So I'm going to go up 2 over 3, up 2 over 3, up 2 over 3. Again, we can follow that pattern backwards. There we are. And then, as always, make sure you graph it with a line through it. Alright. Now let's graph that next one. If you have just been watching me and you haven't paused me, please pause me now and try to graph this one here. And then come back when you're ready. However, hopefully you did graph this already and you're ready to see the answer. So we have -3 down here. And then my slope is 2/3. Up 2 over 3. Up 2 over 3. Up 2 over 3. Okay, then we can go down 2. Again, go in the opposite direction backwards. And then graph it with a line. Aha! So there's something different happening here than up here. So remember, we find a solution by finding where they cross. Now there's something going on here. What do you notice about them? They never cross. In other words, you can say they are parallel. Parallel meaning they run side by side and they're going to go that way for forever. what do you notice about the two slopes of this line? They're the same. We have 2/3 and 2/3. So the slopes are the same. How about the y-intercepts? They're different. Okay, now what do you think this means about the number of solutions? So remember, the number of solutions for a system of equations is where there is a point that both lines are at the same time. So for example, for this system, the solution was right here because both lines were at this point at the same time. They crossed there. So if my lines don't cross at all, what do you think that means about the solution? Is there one? And the answer is no. So today is all about exploring different numbers of solutions for a system. All right. I'm gonna leave it like this. Okay. So this is one of the things we're going to be talking about today. So there's 3 different kinds. One is one we were doing yesterday, where we have one solution. There's one like this, where we have no solution. And then there's a third type we'll talk about at the end. So we're going to just graph all of these first. So let me zoom in closely for us. All right, so we're going to solve this system by graphing. Again, we're going to do it in pink first. We're at a y-intercept of 1, and then my slope is negative x. So down 1, over 1, down 1, over 1, and so on. Beautiful. So now we have our first one graphed. Oh my gosh, that was awful. Oh my gosh, I can't. That one's a little bit better. Okay, so there's our first line. Now let's graph the second line. Solve the following equation by graphing y-intercept of 2, and then we have negative 1/2. So down 1 over 2. Down 1 over 2. Down 1 over 2. And then go back the other way. And then we can plot it with a line. All right, now hopefully you see here that I had 2 dots that overlapped right here. If you ever need to pause me, please do so. Now, because I have this line overlap, that one ordered pair would be my solution. So this would be an example of having one solution. If it crosses one time, one solution. Now, our slopes for this, they're nothing special. As long as we have different slopes, our lines will cross at one point. Okay, so if you notice that you have 2 different slopes on your lines, you can just jump to the assumption and conclusion that these lines are going to cross once. Okay. This one is like the one we just did a second ago. So we have solve the following system of equations. So first we're going to graph this one. There's plus nothing, so our y-intercept for this one is 0. And then we go up 1 over 3, and we can go backwards. And then we can graph it. Okay, and then we're going to graph this next one here. 1/3 x minus 1. So minus 1 is here, and then up 1 over 3. Up 1, or down 1, back 3. And then draw a line. Okay, now here's the example of what we did above, where we saw something with the same slope, and the lines were parallel to each other. So this is what we would call no solution. They never cross. There's no point where they cross, so there's no solution. So for this, we kind of looked at this and realized this above. Okay, this is when we have the same slope, but a different y-intercept. So they start at two different spots, but they're going up and over by the same amount each time, meaning they'll never cross because their rate of change is the same. They're never going to catch up with each other. So we have no solution for that one. And then the last one we have y equals 2x minus 3. So minus 3 is over here. And then 2 over 1. Up 2 over 1. Up 2 over 1. Up 2 over 1. Okay? And then now we'll do this one in green. Negative 3 starts here. And then we have 4 over 2. 1, 2, 3, 4, 1, 2. 1, 2, 3, 4, 1, 2. Aha! So now we have one where my lines, that was really bad, but you could tell from the points that they sit right on top of each other. So these mean they overlap, they cross, they intersect for forever. So what do you think that means about the number of solutions? They're what we call infinite number, or infinite solutions. Now, what do you notice about, let's do the y-intercept first. They're the same. They started at the same exact point. Okay, if they're going to cross forever, what do you think that means about the slope? They're also the same. If you do 4 divided by 2, that's just 2. So, if you have the same slope and the same y-intercept, they're the same exact line, and they're going to overlap for forever. So they have an infinite number of solutions. So below, we're going to try some problems, and there's no graphs. So I want you to just look at one, and then use your rules to help you determine whether it's an infinite, no, or one solution. I'll do this first one with you. So we have 2/5 x minus 3, and then 2/5 x plus 1. Okay, one solution means slopes are different. Well, my slope here is 2/5 and 2/5, so that's slopes are the same. So I know it has to be this one or this one. My y-intercepts are different, so that means it has to be no solution. They're going to start at two different spots, but then go up and over at the same amount each time. They're never going to cross. Okay, so those are the questions I want you to ask yourself. Try these next three. Look at the slopes first. Are they different? And it has to be this answer, one solution. If your slopes are the same, it's going to be one of these two, but then you have to look at the y-intercept to determine whether it's no or infinite. Pause me now and give it a try. Alright, so this one was one solution because we had different slopes. This one was infinite because my y-intercepts are the same and my slopes are the same. We have 3, and then 6 divided by 2 is also 3, so they're the same equation, same line, infinite solutions. This one, my slopes were the same, y-intercepts were different, so they're going to start at different spots, go up and over the same amount forever, therefore never touch. The last thing we're going to do is write a second equation to create a system. So let's say you have the equation y equals 2x plus 4. And I say create a system that would have no solutions. Well, no solutions needs to have the same slope but different y-intercept. So I'm going to write an equation with the same slope but a different starting number. Let's say 2. To have one solution, it needs to have a different slope. So I can just say anything except for 2 here. I could say 5. And then any other number over here. As long as they have different slopes, it's fine. And then an infinite solution means the equations are exactly the same. They have the same slope, same y-intercept. So that means it would have to be y equals 2x plus 4. All right, your goal is to complete number 6 here, and then shoot me a message so I can help you do your independent practice. And yeah. So send me a message, do this one, I'll check your answer, and then I'll help you get to your IP for today. Thanks for watching and doing this with me.